Hi, and this is section 9.3. I'm on page 569. I'm going to write that up here. And this section, I got to turn my layer on. This section is entitled Special Products of Polynomials. Now, when they say special, what they mean by that is there's certain polynomials that we can multiply together, and what by the term special, there's a little shortcut that applies to certain situations. Now, I guess I want to start off, we can actually do all the problems that I'm going to give you in the homework today based on what you learned in 9.2. All right, you learned that if we have a binomial times a binomial, for example, you can double distribute. Or if you have a monomial times a, let's say, trinomial, a monomial, you could single distribute. Or if it's a trinomial times a binomial, you could triple distribute. Okay, so we can apply those same things here. But there are, by special, there are some shortcuts. Now you might be like, well, if I can do every problem based on what I've already learned, why do I need to know the shortcut? I guess what I would say as a teacher is those people that really understand the shortcuts well are going to be able to do the problems quicker, and that's what I would call the A and B students. That means you are not just doing the average. You are more on the high end or on the elite end of what you can do. All right. So I think it kind of comes down to that. How good do you want to be at this stuff? Do you want to be quick at it and efficient? Well, then these shortcuts are good to know. If you are just trying to get by and you figure it's too much to do, if you don't know the shortcuts, that's fine. It will slow you down on a test. That obviously doesn't help. But it doesn't mean that you can't be proficient at what we're trying to do. So there's two shortcuts I want to teach you. The first one's called a square of a binomial, and you can see it's in a blue box on page 569. And the second is called the sum and difference pattern. And there are shortcuts to each. So let's take a look at the square of a binomial. So that means we're taking a binomial and square it. So the first thing is a binomial squared means we're taking x plus 4 times x plus 4. Now let me add something to this because Mr. Keller, he came to my room and he said my kids in my class aren't applying this well. And here's what his kids are doing, and I guess I'm kind of ashamed of it because I know I never taught this, but people, either they forgot or they didn't pay attention. He has students that are taking this and just writing this down. And if you do that, I can promise you that doesn't work. That works out to x squared plus 16. That is the incorrect response to this. Let me show you this with numbers. Let's just pick something easy like 1 plus 4 squared. Now, I think everybody in here or watching knows that 1 plus 4 is 5, 5 squared. The correct answer to this would be 25, right? But look at what happens if you just do what I was showing you here. Look what happens if we just take 1 and square it, and we take 4 and square it, and add those up like I'm showing you here. Does that actually work out to 25? And as you're looking at this, you're probably, I hope you're saying, well, it ends up being 1 plus 16, and that's 17. That's not the correct response because this is not how we apply a square to a binomial. When you square a binomial, that means take, in this case, x plus 4 times x plus 4. So what I would need to do in that case is now this is how I taught you in 9.2, I would double distribute. I would take x times x is x squared, x times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16, and you would get x squared plus 8x plus 16. But there is a shortcut to this problem. Whenever you have a binomial and you square it, there is a shortcut. And I'm going to do that in a different colored pen, and this is how I would do this problem. Here's the shortcut, or this is why they call it special. Whenever you have a binomial and you square it, there's a special shortcut you can apply, and here's all you got to do. Oops, I miswrote that. I wanted to put x plus 4 and square it. Here's all you have to do to apply this special shortcut. You take the first term and you square it, x squared. You take these two terms, x and 4, multiply them together, and double them, and then 4 squared is 16, so you're going to square the first term, you're going to square the last term, and you're going to multiply these two together and double it. And look at what you get. X squared plus 2 times 4 is 8, 8x plus 16. That's the shortcut you can apply when you have a square of a binomial. Okay? You can actually see that applied at the bottom of page 569. They give you 3x plus 4 squared, and I'm just copying this right out of the book. You can see it. Now, you could do it the way I showed you here. You could take 3x plus 4 times 3x plus 4 and actually work out by double distributing like I showed you in section 9.2. But the shortcut to this would just be to say, okay, when I take 3x and squared, I get 9x squared. If I take 3x times 4, that's 12x. If I double that, I get 24x. And if I take 4 squared, I get 16, and I'm telling you that's the correct answer to this in my shortcut. If I actually double distribute it out, I'll get the exact same answer. So again, that's a shortcut that if you notice that I have a binomial being squared, you can always apply, and it kind of avoids you having to double distribute the whole thing out. Now again, if you don't know the shortcut or you don't remember it, that doesn't mean that you're going to get it wrong. It just means that you got to double distribute it, and that takes a little bit more time. And again, when we have a test and it's an hour test, there's a time limit to it. So spending more time on this gives you less time on other things. So again, I would say my straight A students or my A minus or B plus or even B students would at least be able to apply some of these things because that shows that you know this at a higher level than normal, I guess I would look at it. Now again, if you don't do this, that doesn't mean you're wrong. It just means you're going to take more time, and I would call that less efficient. And if you're less efficient, I don't know that I can give out A's and B's for not being totally efficient. I think what I'm saying makes sense. I hope it does to you. If not, ask questions in class tomorrow. There is one more shortcut we need to know, and it's called sum and difference of binomials. Let me put those there so we can start again. Okay, so here are two binomials, and do you see a sum? Remember, sum means add, and a difference. So it's the exact same binomial, other than one's a subtraction, one's an addition. Now, we can always do this problem the way we did in 9.2, which is double distribute. So I did that. 2x times 2x is 4x squared. 2x times positive 3 is 6x. Negative 3 times 2x is negative 6x, and negative 3 times 3 is negative 9. And you notice right here, I'm taking 6x minus 6x, and those, because I have like terms, those cancel out. I get 4x squared minus 9. Now, there is a shortcut to sum and differences of binomials, and let me show you the shortcut for the same problem. And again, this is I've done this for a long time. I notice that when I have a sum and difference of binomials, there is a shortcut. Here's all you got to do. Do you notice how the middle terms just canceled out? They just crossed out because I got 6x and negative 6x. On a sum and difference of binomials, it always works that way. Those middle terms just cancel out. So the shortcut is just take 2x times 2x, which is 4x squared, and then just take negative 3 times 3, which is negative 9, and that's all we have to do. We don't actually have to double distribute the whole thing out. You'll see that in another problem on example 2. I'm on page 570 right now. If you look at example 2, look at part B, we have 3x plus y, and we have 3x minus y. And I notice immediately, wait a minute, I have a sum and difference of the same binomial. So my shortcut would be just multiplying, let me get some color to code this, multiply those two together, which gives me 9x squared, and then if I just multiply these two together, which is negative y squared, I'm done. That's the answer to these two binomials being multiplied. Now, if I did it the old way, if I did it by double distributing, you notice I'm going to get the same response. I will show you. 3x times 3x is 9x squared. 3x times negative y is negative 3xy. y times 3x is positive 3xy, and y times negative y is negative y squared. Do you see right here, I will circle it in blue, that these two are alike, and negative 3xy plus 3xy becomes 0, and you're left with 9x squared minus y squared. So again, if I didn't apply the shortcut, or the special property, I guess, I could still get the answer right. It just required me to do a little bit more work because I got to double distribute the whole thing out and then cancel these out anyway. Where if I just would have applied the shortcut, I would have had it done in 2 quick steps. 3x times 3x is 9x squared, and y times negative y is negative y squared. I would have been done immediately. All right. One other thing they're going to ask you to do is they will ask you to apply special products without your calculator. Okay? And an example of that would be on the bottom of page 570. I should at least walk through this with you before I stop my video. Okay? This would be something I would ask you to do on a quiz or test without a calculator. And this is the kind of stuff that I think, I feel bad in a way. In a way, I kind of sometimes feel like you've been cheated a little bit. You've been allowed to use calculators so soon in life. You never really had to learn these things, and for your parents or myself, you know, when we went to school in the 1970s, 1980s, most of the time, our teachers would not let us use calculators. We didn't have calculators really to use. So these are the kind of shortcuts you had to learn, and it makes mental math, I think, easier for your parents and I, and this is something I'd like to teach you too, okay? So they ask you to multiply 26 times 34. Well, I'll be honest with you, I can't do this off the top of my head, okay? But what I can do is I can manipulate the problem a little bit to make this an easy problem, okay? 26 is the same thing as 30 minus 4. I think you'd all agree with that. And 34 is the same thing as 30 plus 4. Well, just think about what I showed you on the previous slide, a sum and difference of binomials. Do you notice how these are the same binomials, but one's a sum and one's a difference? You ought to be able to apply a shortcut to this really easy. 30 times 30 is 900, and negative 4 times 4 is negative 16. The answer to this has to be whatever 900 minus 16 is. That's 984. Okay? Very easy to see, and very easy, I just made a mental mistake. 900 minus 16, I meant to say 884. That's kind of bad on my part. 900 minus 16, 884. Okay? And you can see it's pretty easy to see that this is pretty easy to calculate out. All right? And you'll see on the bookwork from questions 19 to 22, we have the same kind of thing. Like in number 22, I should maybe do one, they give you 44 squared. Well, I'll be honest with you. I don't have a clue of what 44 squared, but think about this. Isn't 44 squared the same as 40 plus 4 squared? And didn't we just learn a shortcut for a binomial squared? You take the first number and square it. 40 squared, 40 times 40 is 1600. If you take 40 times 4, which is 160, and double it, remember, that was the shortcut we learned on our first slide. When we have a square of a binomial, we take our two terms here, multiply them, and double it, which is what I'm going to do here. So I have 40 times 4, 160. 160 doubled is 320. And then I have 4 squared, which is 16. Well, this is easy now. I got 920 here plus 16. 920 plus 16. Make sure I do my mental math right this time. 936. Okay? Wow, I'm not doing good mental math. 1936, I meant to say. 1600 and 320, 1920 plus 16, 1936. All right, so again, this is something we can do, minimize the amount of mental math, and be able to get this right without a calculator. So anyway, that's where I'm going to stop today. That's all this section is about, is applying those special properties. This keeps this video down not too long here. And if we have questions, we can go over more of these tomorrow.